Hi Distinction family, welcome back to Distinction in Mathematics. If this is your first time, welcome and please join the team by subscribing to this channel. I have been looking forward to this video because this is the first video on functions or graphs. And I have a lot to say about this topic, so let's get right to it. Today we are doing 2023 Supplementary Exam Paper 1, Question 6, and we are doing the whole of this 14 marks. Question 6 is a quadratic function. We have a parabola, and I want us to know these few things before we answer the questions. So generally, this is a quadratic function, and a cannot be equal to 0 when you're dealing with quadratic functions. If a is equal to 0, then we are moving away from a parabola because it's not going to give you a curve. Now, I want you to note that the shape of your graph depends on the value of a. So if a is greater than 0, your graph faces upwards. And if a is less than 0, your graph faces downwards. Now let's go to the questions. First of all, we have to acknowledge what we have and what we are given, because you're going to use that to answer all the questions. So we have the graph of f at x, which has the value of a that is negative, hence why your graph is facing downwards. We are given c, the y-intercept, and we know that a and b are the x-intercept, and the coordinates of d, where k is the y value. 6.1 is calculate the coordinates of E, the turning point of F. So to find the coordinates of the turning point of this graph, you have to find the derivative of f at x, which is our graph, equate it to 0 and solve for x, and that is going to be the x value of the turning point. So let's do it together. So this is the simple way of finding the x value of the turning point by equating the derivative of f at x to 0 and solving for x. But please don't make a mistake, this is not the same case with the value of y. When you need to find the value of y, you substitute the value of x on f at x, not the derivative of f at x. So please keep that in mind. So now instead of x, we will have minus 3, and let us solve for the value of y. Six 6.2 is write down the value of k. K is the y-coordinate of the point D, which lies on the graph. So what you're going to do is we're going to find out what is the value of y on the graph, where x is minus 5. The easy way to do that is to substitute minus 5 as an x value on f at x and solve for y. So let's do it together. Six 6.3 is determine the equation of the straight line passing through CD. Now we have the coordinates of D and we have the coordinates of C. Remember, we're given that C is the y-intercept of F, and the y-intercept is represented by this value, which is 7, where the value of x is 0 on the graph. So to find the equation of the line CD, we can use this general form of the straight line function. As long as we have these two coordinates, we can be able to find the equation of this straight line. And we already have the value of c, which is 7, which is the point at which this straight line intersects the graph at the y-axis. What we do not have is the value of m, which is the gradient, and we're going to use these two coordinates CD to find the gradient. 6.4 is a tangent parallel to CD touches F at P. Determine the coordinates of P. Always keep in mind that parallel lines have the same gradient. So because of that reason, we already have the gradient of the tangent that touches F at P. So because it actually touches at F, now we have to find the derivative of F at X and then equate it to the gradient, which is -1, and then solve for X, which is going to be the X value of P. So let's do it together. Okay, so remember again, to find the value of y, you substitute the value of x on the original equation of f at x and not its derivative. So instead of x, you are now going to have -5/2, and that is how you're going to get the y value. .5 is for which values of x will f at x minus 12 be greater than 0. So now the value of c in a parabola, which is this one, is responsible for the shifting upwards or downwards of your graph. So the fact that we have 7 as the value of c, which is the y-intercept of the graph, tells us that the graph shifted 7 times upwards. So what they're actually asking us right now is if this graph shifted 12 times downwards from this point, what would be the values of x where f at x is greater than 0? So that's going to be f at x minus 12 greater than 0 as written in the question paper. And then we group the like terms. Now this step shows the perfect equation where f at x has shifted 12 times downwards. And if you were to draw the graph of this equation, you will have something like this. The y-intercept is clearly shown, and before we even solve for x and find the values of x where f at x is greater than 0, we can already see from this graph that this section above these points and this point, f at x is greater than 0. So let's take this to the other side of the greater sign and solve for x. So the values of x where f at x minus 12 is greater than 0 is when x is greater than -5 and less than -1. And that is the end of this video. If you haven't subscribed, please subscribe and join the team. And if you think this video was helpful, please give it a like, and we'll see you on the next video.